Hello YouTube, and welcome to my first video on this new channel that I call Probably Accurate. Anyway, the point of this channel is to share a unique perspective. Climate change is certainly one of these topics that's been on my mind recently, and but although this channel is not going to be dedicated to climate change at all, there's a lot of topics that I'd like to share and talk about and look at the data surrounding. And climate change is very important to me, but it's not going to be a reoccurring theme. Maybe someday there'll be something about climate change, another aspect of it, but that's not the point of this channel. So let's get started and talk about climate change. And I'm going to start this out with a little bit of context about me and the focus of my group. Whether you are a climate change denier and in that bucket, or a climate change alarmist and over there, or somewhere in the middle, I encourage you to hang in there with me to the end of the third slide in this presentation. And if at that point you feel like you've seen this is nothing new, or it's not interesting, or you just don't even want to believe what I'm saying, then, tune out, and I understand that. But if you hang in there for just a few minutes, a couple minutes, I think you might understand why I believe that my perspective is legitimate and maybe worth looking at and considering as a new way to focus on climate change. Okay, now the picture on the screen here is one that I took in my backyard. This is a Japanese maple growing in my backyard, and I think that's important context because I planted this tree when it was about 2 feet tall, and I've grown it into this size tree. This is not the only one. I have several Japanese maples around my yard. This picture was taken by walking up under the tree, looking up into the sky, so it's a very large tree at this point. I like nature. I love nature. I think it's very interesting, and I do everything I can to figure out ways of accelerating it and really putting it to work. So I also grow fruit trees, vegetable gardens. I compost. I've got 2 hot compost piles in my backyard. I got 2 cold compost piles in my backyard. I also make compost tea. If you're not familiar with that, it's a way of fertilizing your plants and extending the use of your compost. So anyway, the point is, I work with nature. I really do enjoy getting my hands in the dirt, and so this topic of climate change, I believe, is very serious and something that we should all take a little bit of time to understand better. So these are the kinds of reasons I felt inspired to create this presentation. All right, and I'll talk a little bit more about myself in a moment. But first, while we're talking about nature, I wanted to bring up in slide 2, being irresponsible with the planet is a bad idea. And this is not something I say because I'm a Greenpeace advocate or a climate change alarmist and we need to do something here. It should be common sense for everybody. We are filling our landfills. If we have the option to recycle or the option to create products that break down faster in our landfills, why on earth wouldn't we do it? It just makes sense. So I encourage everybody to recycle and reuse and reduce, and I do this myself. This is something else I take pretty serious. And so I'm not one of these people that's just coming out and saying certain components of climate change are just, junk science and so forth. I do feel like this is an important topic. Now, that said, I often get put in the bucket of save our planet. It seems like a natural progression. If you're somebody that recycles and loves nature, you also are wanting to save our planet. Well, the truth is that's not true at all. I think that is a marketing lever that is being used to justify spending a lot of money, and that is really the point of this presentation. Not to debunk the idea that the Earth is warming necessarily, and we'll talk about this in the next slide a little bit more, but just the idea that we as humans can change the weather. We're not there yet. We don't have that kind of power, or if we do, it's not just because of something that we're doing in our daily life. Okay, so you'll understand this more as we get into it, but this is really setting the stage for what I'm trying to focus on with this particular video. I'll tell you straight up, I am not a scientist. I am not trained to be a scientist. I didn't go to college with any aspiration of being a scientist, and certainly not in the climate industry. Can't claim to even be close to it. However, I am very experienced and highly trained to analyze massive amounts of data in the search for the truth. I do this for my work, my day job, if you will, and so I'm looking at corporate data. I'm looking at all kinds of data that they throw at me, and my job is to understand enough about whatever subject area they ask me to look into that I can look at the data, add some context, understand and identify patterns and red flags, and eventually get to the truth, and the truth being my perspective on the data. Okay, so I bring that to the table, and what I'm doing is I'm taking all the data that actual scientists have created and compiled, and I'm looking at it all. And then I'm putting together patterns and trying to bring out some things. And there's a couple of things that I want to share with you. All right, so what I believe the data is telling us can be summed up in these 4 bullet points. Number 1, Earth is warming. It just is. And to say it's not, there may be a slight break or a pause, if you will, but if you go back 100 years, if you look at the age of the planet, if you track the trends, there can be no denying that Earth is warming. So let's just get that right out there. And then Earth is changing. Not only is the planet warming, but it's changing. And we'll talk more about that during the presentation as well. There is a potential global crisis for humans. We're not killing the planet. The planet's going to be just fine. The planet may change. What we are doing is we are exterminating ourselves. So when people say we're killing the planet, what they're really saying is we're killing the human race, and I think that's some important context. I don't think that we as humans are killing the human race by altering the planet, but I do think that there is a potential global crisis that is related to global warming. So human activity is having an immeasurably small impact on climate. And I chose these words very, very carefully, immeasurably small impact. So we are having an impact. Of course we are. Everyone inhales and exhales. You exhale a greenhouse gas, CO2. Is green. Well, anyway, let's move on to the next slide, and we'll address this specifically on the next slide. So that's slide 3. If you continue to be interested, hang in there with me. Next, we're going to talk about 2 questions that global warming advocates or alarmists, that's a harsh term, but on that side of the discussion, always seem to ask. It's like programmed as a part of their mission to convince people that humans are responsible for climate change. So the question is, are humans responsible for pumping an increasing volume of CO2 into the atmosphere every year? There's only one answer. Of course we are. Again, the data is overwhelming. Industry is growing. We are doing things to stem, gas mileage is going up. We have filters for, clean coal production and burning and so forth. And we're doing some great things. But the bottom line is that we are increasing the volume of CO2 we're putting into the atmosphere every year. So then they go into the next question. If it's true that humans are generating CO2 at an increasing rate and that CO2 is a greenhouse gas, can we agree that humans are responsible for global warming? And this is where the first part, absolutely, as we talked about in response to the first question. The second part, CO2 is a greenhouse gas. We can all agree on that. But this third part, can we agree that humans are responsible for global warming? That is such a stretch. And so it's impossible to answer this question, because the only answer that you can give to this question is yes, humans are responsible for global warming. But that does not give you an accurate picture of what's actually going on. So I answer that question with a question. If I toss a pebble into the ocean, am I responsible for an increase in sea level? See, it's a trap to respond to a trap, because the answer, of course, is yes. You can't deny, even the smallest pebble into any volume of water is going to increase the mass, the volume that's in that water, and therefore the level of that water will rise. You can do this in a glass. Put a rock in a glass of water, and you'll see that the glass appears to be more full, because it is. There's a rock in there now. So if I toss the smallest pebble into the ocean, I am, no way around it, increasing sea level. But does that mean that it's in any way significant? Okay, you're starting to see where I'm going with this, right? So now, we'll continue on. Let's look at it a different way. CO2, and we've probably all seen this picture or something very similar. We were taught this in school. It's a very, very common image showing kind of the cycle of life for CO2. On the far left, we have a respiration. That's cows, and any animal, in fact, dogs, cats, monkeys, everything. Everything that breathes is breathing in oxygen and exhaling CO2 to some degree. That CO2 is going into the atmosphere. They got trees in here showing photosynthesis, so taking CO2 and sunlight and turning it into energy and actually oxygen. All these things, when they die, they break down into carbon, go in there and cause dirt, create dirt, and so forth, and that turns into fossil fuels, and we dig the fossil fuels up. You can see coming up under the truck and industry and microbes. And the microbes are also creating CO2. You get the idea. It's a common cycle. And then right in the middle is this huge area that's human activity. So agriculture, industry, trucks, cars, airplanes, the amount of CO2 that humans are responsible for is huge, according to this diagram. At the very least, we must agree that what humans are responsible for in the atmosphere is not fair, according to Mother Nature. We're doing things that are not natural with industry and burning, in our cars and so forth. Can't deny this. I mean, this is a point worth arguing. And again, I do care about the environment, and I want to reduce these things as much as we can. I don't want to intentionally do damage. But we're making an argument here about CO2, and we're trying to decide, is CO2 really a problem today? And even more so, is human activity a major contributor to that? So there's a couple things that didn't make it into this little diagram that are actually extremely important. First of all, a little piece of data. Now, if you ask global warming alarmists, and again, I'm going to continue using that term, but I don't mean it in an insulting way or harsh way, just people that believe in this global warming CO2 crisis. If you ask them what percentage, how much CO2, what percent of the CO2 in the environment is caused by humans, they struggle to give you an answer. But there are a couple studies out there that make some reasonable estimates, I believe, based on the data. And they all come in somewhere around 3, maybe as high as 5% of the CO2 levels. Now that percent is small, but I think it's important to note that that could be extremely significant. So we're not debunking anything yet. If 3% of a small volume could easily create this argument that global warming people and climatologists have been talking about, where humans are responsible for creating a tipping point. We are the straw that broke the camel's back, right? And it's a lot more than a straw, in fact. 3%, when we're talking about the atmosphere, could be a big straw. So we have to understand more about CO2 to really pull this into context, and that's what we're about to do. A couple other things here, real quick. Volcanoes. There's a lot of studies out there, and I've seen it over and over again, so it's pretty well validated that one belch, one volcanic eruption, sends more CO2 into the atmosphere than humans create with all this other stuff in 10 years or 8 years. Let's say 8, go on the low end. But still, that's pretty crazy, right? Because I'm telling you, and we'll talk about later in the presentation, there's a lot more volcanic activity than you probably realize. So another data point worth mentioning that I found is things like termites. A lot of skeptics like to bring up the idea of termites because there's a group, and this is, I think, interesting. It's probably exaggerated to some degree, but there's a lot of termites in the world. I didn't realize until I looked into it exactly how incredibly common termites are. But these little buggers, they eat wood, and so the byproduct of that winds up being CO2. And so they actually produce, and this is you have to estimate how many termites there are in the world, but approximately 10 times as much CO2 as humans do. That's one bug. So even if you want to go conservative, say 5 times as much. That's half of what the scientists have estimated. So there's a lot of things that create CO2. And so the whole point of this slide is to say what we have to understand is how big CO2 is. Is it and the assumption is because trees breathe it, because every green thing and plant uses CO2 to survive, that it must be about equal to the volume of oxygen in our atmosphere. And we'll talk about that here. So let's look at some charts. I'm going to go through a couple pie charts here. This is the very common one. I see this a lot with global warming people and climatologists trot this one out. Talking about carbon dioxide being 64% of all the greenhouse gases in our atmosphere. And they'll say that. And it's not that it's not, well, it is not true, and I'll address that in just a moment, but among the common greenhouse gases, the ones that are stable in our atmosphere, that's really what they're saying, carbon dioxide is 64%. So here you can see it. Methane comes in number 2, and so forth and so on down the line. But you've probably also heard in the news and elsewhere that there is a much, much more common greenhouse gas in our environment, in our atmosphere, than CO2. Water vapor. It's actually way more prevalent than carbon dioxide. Way, way, way more prevalent. I don't know, this pie chart, I'm going to call it accurate, but I will tell you what I've learned about why climatologists and global warming people don't include water vapor in their numbers. It's because it changes so much. It depends on temperature. If it's really cold, the air is drier. If it's really warm, humidity goes up. Deserts versus tropical areas versus atmospheric changes. At what level in the atmosphere do you want to measure the water vapor? Some strata of our atmosphere have really high concentrations of water vapor. Others, almost none. So it's impossible to say that this is a stable gas in our atmosphere. There's just a lot of it, a lot. Okay, so it's hard to really do a lot of math with something that varies so radically, but it is out there, and there's a lot of it. Okay, so now I've addressed water vapor. The next thing is this chart. I see this one a fair amount when we're talking about all the gases, not just greenhouse, in our atmosphere. Look at what happens to carbon dioxide. Nitrogen is 78% of the gases in our atmosphere. Oxygen, 21%. And then inactive gases, which a lot of people call greenhouse gases. A lot of people just call that, other gases, which is probably more accurate. But inactive gases is also true. It's not things that we all use, I guess, as much. I'm not sure why they call it inactive, to be honest with you. But water vapor is not a part of that 1%. So you don't have to go, assuming that that's where I'm going with this. The point is, 1% of all the gases in the atmosphere make up where the carbon dioxide resides, and according to the upper left corner, carbon dioxide is 64% of that 1%. But see, that's not even true. Let's look at NASA. So there's our, in the pie chart, you can see our 78% of nitrogen. You can see our 21%, 20.9% oxygen, and then there's our 1%, just like we saw in the last chart. But look at what the yellow area represents. Argon. You know, how many people think about argon? Well, it's not a greenhouse gas, that's for sure. But it's making up about, let's see, 93% of that 1%. The truth is, carbon dioxide, if you look on the left side of the screen, makes up 0.034, 34 100ths of 1% of our atmosphere. Okay? That is a very low number. In fact, now we add back the fact that humans contribute 3% to all the carbon dioxide in the atmosphere. And what you then understand is that the human contribution to CO2 today in our industrial age is 0.001%. It's ridiculously small percent of our total atmosphere. And you think about how greenhouse works, you really have to start to ask yourself, what are we doing? If we're spending trillions of dollars in an attempt to reduce greenhouse gases by, whatever, 10%, maybe, 10%, when all we're creating is 0.001%, it just doesn't make sense, right? So this is the story of CO2, and I just wanted to kind of share this with the YouTube community and anybody that might be interested and maybe had not looked at the data this way. The core of the climate change, climate alarmist premise for CO2 does not make sense. Not to me anyway. And so perhaps we could say that carbon CO2 is so powerful that 0.001% is significant. But I have not seen that in the data. There's nothing to tell me that it is. So anyway, there you have it. But I've got more. Let's take a look at the. Oh, in fact, just real quick, Big Ben, the clock tower in the UK, is 319 feet tall. Just to give some context here, all the CO2 in our entire atmosphere would be 1.25 inches on the top of Big Ben. When we look at the human contribution to CO2, we're looking at 1 millimeter on the top of Big Ben. So 1 millimeter of the total height of this building is how much humans contribute to CO2 in the atmosphere. All right. Okay, and so I think I've drilled that into the ground thoroughly. The next topic here is that CO2 is a cycle, right? And there's some things that we need to know. Things that use, all our plants are using CO2. We're creating CO2. So it's a part of a circle, right? So something that I noticed, and I thought this was some interesting data, during seasons where weather is still and air is not moving, plants in the middle of these giant fields, crops, have been seen to grow far slower than plants on the edge of the field. In fact, plants in the middle are more prone to disease. They generate lower volumes of fruit. The plants on the edge of the field are always stronger, healthier, taller, and produce more fruit. Isn't that strange? And so they did a study, and what they found is that all the CO2 is being used up. So if it's not windy, if there's just not enough breeze, and this apparently happens, then these giant fields of corn or soybeans or whatever it is that the farmers are growing wind up really suffocating, literally. They've got no food. They breathe CO2. They need it. So the point I'm making here is that in the past, there is data to show, and scientists seem to have a fairly reasonable consensus on this, CO2 has been CO2 levels have been far higher than they are today. In fact, you could almost say that for the volume of life and plants that are growing on this planet, it's almost at a critical low at this point. And there are actually some scientists that say that and believe that. Okay. Meanwhile, the opposite is also true. We've learned in greenhouse growing and so forth that dramatically increasing CO2 levels results in faster growth, better plant health, and higher, better quality of marketable products. So greenhouse operators have taken on this practice of actually either using natural gas and burning it, byproduct being CO2, to push that into the greenhouses. This example here I thought was very cool. It's milk crates hanging from the ceiling with dry ice, which is frozen CO2, being put in them to just dissolve in the heat. Thing is, I guess the next logical question is, okay, it's good for plants. Are we killing humans with this level of CO2? And the answer is no. What I've learned is that even astronauts in space, or people in confined areas, or if you sleep with your room door closed and things like that, your CO2 levels go up dramatically, maybe even 2-3 times. Remember, it's only a small little fraction of your total atmosphere. So it's very easy to double it, especially if you're exhaling in a small room. Okay? So we're fine as humans with much higher CO2 levels. So here's how it works. I just thought I'd share. CO2 goes into the greenhouse or the whatever the vessel is. Plants go crazy and start just really processing that CO2, and the byproduct of that is oxygen and nitrogen back into the atmosphere. So good stuff, right? No negative byproducts. This is a very natural process, and it's what makes life work here on Earth. Okay, so CO2 is not our enemy. In fact, plants will thrive. So another way of looking at this, current CO2 levels in the environment are adequate to support plant life, but low according to historical standards, just because they have been so much higher. Plants actually thrive with far higher levels of CO2, which we just talked about. Larger plants create more shade and cooler microclimates under the canopy. Now we're talking global warming, right? We're talking about CO2 cooling the planet through what it does with plants. More biomass on the ground. Leaves fall to the ground in the fall, lead to a much richer cycle of life. Bugs and ants and everything gets in those leaves and starts eating. The birds eat the bugs and so forth. So your whole ecosystem is built up and stronger when there's more CO2 in the environment. Shade leads to slower water evaporation into the atmosphere. And as we've talked about, there's a huge amount of water vapor in our atmosphere. So increasing CO2 leads to bigger plants, leads to more shade, leads to lower evaporation and less of this deadly water vapor in our atmosphere. So all good stuff. CO2 is our friend. It is not our enemy, is what I'm trying to drive at here. The other thing climatologists will tell you, and the data that I looked at, is oceans store CO2, and we are seeing an increase in the level of CO2 in the oceans. This is true. Okay, I'm not here to say the data they're sharing is false. I have no reason not to believe the data. It doesn't look fraudulent, and I tend to notice red flags if I believe it is or if it is. So it looks like honest, legitimate data, and it makes sense. And we'll talk about why in just a moment. But the CO2 levels in our oceans are increasing, most interestingly in the deepest parts of the ocean. And we'll talk about why in just a moment. But the bottom line is, in my note up here, oceans store CO2 in case plants eat too much. So if the CO2 in the atmosphere gets so high that the plants are just eating too much and just growing way too much, well, the ocean has the ability to absorb some of that as a balance. And that's what climatologists tell us, is that because the water is absorbing, it tells us that CO2 levels are extreme in the air. Now, that's not true, because we just talked about how plants could use a lot more CO2. Okay? So I think we need to talk a little bit about phytoplankton, which is like the plants of the ocean. Phytoplankton are tiny little one-cell organisms that are plants. They use photosynthesis. And there's as low as 50%, but many scientists believe that phytoplankton is responsible for as much as 85% of the oxygen in our atmosphere, the 20% of our atmosphere that is oxygen. These little guys that you can't even see are responsible for it. So they take sunlight, they take nutrients in the water, and they bloom. So when CO2 is high, and you see pictures like this from from climate change people saying that's because it's an industrial area and all that CO2 is going to the ocean and making these phytoplankton go crazy. Maybe, but not so much. These phytoplankton grow where it's warmer water, where there's nutrients, and where there's CO2. It's true. But there's a lot of things that can contribute to CO2 in the water. Frankly, smokestacks and exhaling in cars, it's going to be a lot more dispersed than what we see here. Everything that I've seen in the data shows that would be a very dispersed area. Also, I think in pictures like this, which should jump out at you, is the fact that if we have some kind of unreasonably high atmospheric CO2, we would be seeing, our entire ocean would look like these bright blue areas. Okay, one more data point here. These guys can divide really fast, by the way. So if CO2 goes up, they start munching, right? So any CO2 that the ocean absorbs starts getting eaten right at the surface very quickly. But the thing is that only a small percentage of the phytoplankton can be seen like this. So there's actually a lot more in there. It's a very small percent of all phytoplankton. You have to think of it like a tree, right? Compared to all the trees and grass and plants on Earth, on land. The diversity of phytoplankton is no less significant. Okay, so some of them glow, some of them don't. Some of them will, appear to be lighter in color. Some of them aren't. They're as diverse as land-based plants. Okay, but that's phytoplankton. That's the ocean, and that's what I've learned. The data is telling us about the ocean and CO2. So here's the leap, right? All of a sudden we're out in space. I'm just going to spend a minute on this, but the thing is that the next thing that a lot of climate scientists will say, if it's not CO2, what is it? And the biggest theory out there is that it's the sun. The sun must be warming up. It's heating our planet. Okay, so let's look at that. I looked at all our planets and all the data, and there's actually, you'd be surprised, a lot. We have the capability now to gather some really detailed information about planets in our solar system. And we have the technology with Hubble and with all the different tools that are in space now to really focus on planets, look at them, and study them. Okay, so what I found is that we'll start with Earth. We know Earth is warming. Mars is also growing. Mars has got these CO2 actual ice caps. It's cold enough that the CO2 is frozen like dry ice. That's melting. So Mars is definitely warming. Jupiter, oh my goodness, the news on Jupiter is just huge. The cloud formations are changing in ways that we've never seen before. The red dot on Jupiter is growing, but there's also a second dot forming now. So all of these are signs, according to the scientists that know this stuff, that Jupiter is definitely warming. In fact, Europa and the moons of Jupiter, Europa is an ice planet, and they started seeing signs of water, geysers shooting up. So a lot of warming going on there. You move out to Saturn. Yep, warming. In fact, the axis is tilting a little bit. It's also warming, and the rings are changing right before our eyes. And that's unique. Haven't seen this extreme level of warming in the past, so it's safe to say it is warming, just like Earth is, perhaps even more. Uranus, interesting planet because it's an anomaly. If you're not aware, I'll share a little trivia with you. Uranus is closer to the sun than Neptune, but Uranus is actually colder than Neptune, and that's a scientific conundrum. Why? They're so similar. But nevertheless, although it's colder than Neptune, it's warming up. So is Neptune. Axes of both planets have shifted a bit. Moons have shown signs of warning. And then I went ahead and drew in myself a little bitty Pluto. Trivia on Pluto that I found interesting. Pluto is actually, it's not, should not be surprising to anybody. It's not called a planet anymore. Something I didn't really know until I started looking at this is that Pluto as a planet, as an object, is smaller than Earth's moon. So it makes sense that it's not. However, it's also it's so far out there. It orbits the sun every 200 and, I believe it's 240 some odd, you may have to correct me on that, but 200 and some odd years. Let's just leave it there. It takes a long time in an elliptical orbit for Pluto, a strange elliptical orbit, to get around the sun. So all the time that we've been measuring Pluto, we are seeing Pluto warm, that far out from the sun. The thing is, Pluto is actually in its elliptical orbit going away from the sun, and it's warming, and it's the furthest out object that we're tracking like this. All right, so something's definitely happening, and this is the kind of reason that people say maybe the sun's doing something to heat our planet as well. Makes sense, right? Well, there's two planets I haven't talked about, Mercury and Venus, and the reason is not a lot of data, not a lot of interesting data. Truth is that everything's always changing in the solar system and all, but there's no notable change, climate change or otherwise, on these two planets, which are the closest to a sun, which in this theory is supposed to be heating up Pluto. We should be seeing massive changes on Mercury and Venus, and we're not. Naturally, I've got to address the fact that we've also got satellites looking directly at the sun. And if anything, the sun seems to be cooling. And I've seen stories on both sides of this, but it certainly doesn't seem to be doing this kind of warming that's going to heat up the solar system. So, weird, right? I'm not drawing conclusions, I'm sharing data, and that's what's going on in the solar system. We're not the only ones warming. Let's bring it back down to Earth. On Earth, these are volcanoes and earthquakes. You can kind of see the tectonic plates showing up here in this little diagram. But we are having a lot of earthquakes and volcanoes increasing. And climatologists again would say, we told you so, this is going to happen. But I mean, that's, again, you just kind of scratch your head and say, wait a minute. Humans are putting CO2, this trace element, into the atmosphere, and somehow it's causing earthquakes? And they've got some theory for why and so forth. But it just, at face value, you have to kind of wonder if that really makes sense, right? Maybe it does. I mean, they're scientists. But the thing is that I notice there's a lot of activity going on. I also noticed, and I started looking into these volcanoes that are in the deep water of the ocean and so forth. They are pushing lava, right? The center of Earth up through the crust, which is over 2,000, it's thousands of degrees, 2,000 degrees Fahrenheit. That's of course warming the water all around it, and this is happening everywhere. In fact, they've measured water around these eruptions, and it's like 750 degrees. So ongoing, active volcanoes. Well, you're heating the oceans. That's a lot of activity. And, you look at a diagram like this and you say, well, yeah, but maybe some of these volcanoes are actually, and these earthquakes, which many people, oftentimes an earthquake it's a tectonic plate moving, and so lava comes up, in the gap between the plates and so forth. Maybe not technically a volcano, but volcanic action is happening there. So you have to keep that in mind. Earthquakes, volcanoes, kind of the same thing in a lot of ways. But this is a lot going on. I downloaded a little app called Earthquake 3D. It's a free application. You can grab it and check this out for yourself. But on October 18th, I pulled up Earth. I set it to look at the last 7 days, 1 week. And I said, show me only earthquakes 4.0 or greater. And this is the image that came up. If you're not surprised by this, you do research into earthquakes, because I don't think most people understand how many earthquakes are happening these days. In fact, in the upper left corner of the globe there, you can see an earthquake swarm, I guess they call it. That's right around Greece. And there was a 5.5 earthquake, and that did make a little bit of news, but there's been a lot. And every one of those is 4.0 or greater, so a major earthquake. So we are seeing a lot of earthquake activity. Last piece of data, and then we're going to wrap up. Earth's core. There's a reasonable consensus around the idea that Earth's core is warming. Now, why is this so significant, and why does this seem to be the case? All the data lines up behind this. What a consensus scientists have said, and by that I mean 50% or greater. I'm not assuming a 97% settled science, but a consensus has said what's going on is Earth's core is heating up, and that's causing liquefaction. So the mantle and so forth is more liquidy, and that's making the crust float a little more and crack, and that's what's giving us all these earthquakes and so forth. Okay, I mean, I'll buy that. That makes actually really good logical sense. But the real question we should be asking is, what is causing the center of our planet to warm up? What's causing planetary warming in other planets in our solar system? It's easy to see, and I'll make this last point. The center of the Earth is warming up. Earthquakes are happening on the bottom of the ocean. Extremely hot water and large volumes of CO2 are going into the water. This explains two things. The oceans are warming. The oceans, there's tons of evidence, permafrost all the way to glaciers, that these things are melting from underneath. And if you want to look that up and Google it, you'll see. I was kind of surprised how many of the glaciers are actually melting from underneath, not warm air, warm ground. So the oceans are warming and sea levels coming up, and CO2 levels are going up because of all the earthquake activity that we see here. All of this makes sense. What's happening to Earth is the core is warming up. And I don't claim to have the answers. I do have a belief. I think that I understand what scientifically would cause that, but it's not. Let's just say there's not a consensus around it. This is just me, and so I'm not going to share this as a part of this video. Maybe in the future, if you're interested, I could share it if you like the content in this video and it has inspired some thought. But I encourage you to take what I'm sharing here. My goal is only to share the data that might help you understand the questions that we should be asking. Questions are great for Google. Put your questions in Google. Do a little research and see what you find. Why is Earth's core heating? Is a good search. That's a good place to start. And I encourage you to do that. Anyway, I hope this has been entertaining to some degree, not just totally boring data. I hope that you found it interesting information, and I hope that it inspires you to ask more questions and not just take at face value what we're being told about climate change. Of course, you could ask, if this stuff is so obvious, why are they telling us that CO2 is the problem if it's so obviously not? Well, that's a good question. I would say Google that one. But that's not what we're here to discuss today. I'm just trying to share the information and inspire thought. If you like this video, please like it, share it, subscribe if you like the idea of this new channel. Again, I'm not going to be focused on climate change. This is one topic, and I've pretty much shared everything that I want to share at this point with regard to climate change. I've got some other really interesting, I think, topics that I might cover with some data analysis and breaking down in the same way that I'm looking at climate change. But I wish you the best of day or night or morning, depending on where you are and what time you're viewing this. And I hope you enjoyed the content. I look forward to any feedback or notes in the comment fields below. Have a great day.